All right, so welcome back. Anyway, we're going to be finishing up 4.3 in this section. It's called Properties of Definite Integrals. You'll notice that I kind of did a definite integral in the last video where I found x squared plus 1 from 0 to 2 of whatever that value was, what was like 4.6 repeated or something like that. A definite integral is basically going to be used to notate finding the area underneath a curve. Okay, so finding the area underneath a curve. What the indefinite integral is just used to find the antiderivative. Antiderivative. The difference between an indefinite versus a definite. An indefinite will look like this with some f of x dx, where the definite will look like the integral of f of x dx from a to b. So there's numbers here, there's no numbers there from where to where, so that's the difference between definite versus indefinite, and it has it right there. If the function f is continuous on the closed interval a to b, then the area of the region bounded by the graph is this here. That's very similar to what we did, or what we talked about in a couple videos ago, where we had the limit from n to infinity of that summation from I to n of f of x times f of xi times delta x. It's basically what this is. This is f of xi times delta x. That's basically the same formula. It just looks different, but it's the same exact thing. Okay, and so now what I want to do is the value of a is always the leftmost, okay, and the value of b is always the rightmost. So it always has to be that way. So the bottom number always has to be smaller than the top number. Obviously, you think that makes sense, but you'd be surprised at how often we don't change that. And so the definite integral is an accumulator of area. This means that area adds to its value as it moves from left to right. Okay? If the value of b is smaller than a, then the area is moving backward and will be negative. Okay? So if a is on top but it's actually smaller than b, in order to get a on the bottom, okay, in order to get a on the bottom, I have to put the negative outside and then flip the two bounds. So this is called bounds. All right, a and b, those are what we call like leftmost bound and uppermost bound, or bottommost bound, stuff like that. All right, so for instance, if here's some numbers, so if I'm going from f of x dx from 4 to 1, in order to change this, I have to take a negative out front, and then it's now from 1 to 4. Hopefully you remember that from last year. All right. Okay. Where else are we? Areas above the x-axis are considered positive, while areas under the x-axis are negative. Ooh, negative. Sorry, that was terrible. This is Monster, this Hydro, brought to you by Monster. It's like 10:20 right now. It's my third video in a row. I'm just going for it. Actually, it's my like fifth video. I don't even know. This means that a negative area while moving right to left would be counted as positive. So, for instance, if I'm going from 4 to 1 of f of x dx, this is some positive value. When I were to write this, okay, this would be negative from 1 to 4 of f of x dx. Because this is negative, that means this is also going to be negative. So therefore, that's going to be negative, and therefore, again, a positive value. It's going to negate itself. Okay. All right, here we go. Here's some properties here. So example, on this graph, from 0 to 1 of f of x dx, from 0 to 1, that area is telling me it's 2, so we're going to say it's 2. Okay. From 0 to 4, we're going to now say that I'm going to add up from 0 to 4. So 0, 1, 2, 3, and 4 right there. So if we know that's 2, we're going to get 2 plus the 6, and that's going to be a total of 8. From 1 to 6, 1 is right there, 6 is right here. So that's 6, but minus 3, because 3 is underneath, and therefore we get 3. From 4 to 8, from 4 right here to 8, which is over here, we know that that's 3, but that's negative 3, plus 7. So negative 3 plus 7 is positive 4. From 0 to 8, I'm basically taking up each individual section and adding it. So it's 2 plus 6 minus 3 plus 7. So I get 8, 15, I get 12, I believe is my answer. Yep. And then from 1 to 4, or from 4 to 1. So now I'm going backwards. Okay. So this is the same as saying from 1 to 4, f of x dx. From 1 to 4 is 6, right? Just like it was right here, we kind of split it up. So 1 to 4 is 6, but it's negative, so this is a negative 6. All right? All right. For some reason, I changed shirts. No, I'm just kidding. It was been a couple days. I got busy, and I had to stop the video. So coming back to it. We got to finish up. What do we got to finish up? We got to finish up this last problem here. If f of 8 is equal to 4, I want to find the absolute minimum value of f on that closed interval. So there's a couple different ways we can do it. One is because we're starting at 0 and we're going to 8, we have to use the bounds. So use the bounds. Okay, and then we have to find another value that we care about in terms of what does it mean to be an absolute minimum. So minimum, right, is going from negative to positive. So the only piece of the graph here goes from negative to positive, that's 6. Okay, so I'm going to check 0, I'm going to check 6, and I'm going to check 8. Those are the only 3 values, 3 critical points that we need. You can check all of them if you so choose, but it's not necessary to do so. Now we need to know, okay, so I need to find out f of 0, right? So f of 0 is equal to f of 8 plus, I gotta go backwards. So the only value I'm given is f of 8 right here. So I have to find the area backwards. So I'm going to go from 8 to 0 of f prime of 8 dx, right? And another way I can write that is just saying that it's really f of 8 minus from 0 to 8 of f prime. Oops, I put another parentheses in there I didn't need, but that's okay. And so f of 8 we know is 4. F prime of 8, I'm sorry, f prime of x, this should be an x there, not an 8. And I want to find that area, right? So this is 2 plus 6 is 8, minus 3 is 5. 5 plus 7 is 12. And so I get 4 minus 12, and that's negative 8. So that's what f of 0 is equal to. Then I got to find out the 6 value. So f of 6 is equal to f of 8 plus the integral from 8 to 6 of f prime of x dx. But then that, f of 8 minus, so I got to flip this around, okay, from 6 to 8 of f prime of x dx. And that's going to be equal to f prime of 8, again, is 4. From 6 to 8 is 7, so 4 minus 7 is negative 3. Okay, so that's what f of 6 is equal to. And then I want to find out what f of 8 is. Well, that tells us what f of 8 is positive 4. So I have my 3 values. I have negative 8, negative 3, and positive 4. And because we're looking for the absolute minimum value, then that means the minimum value is 8. Remember, the minimum value is the y value of the function, and so the minimum value is negative 8 on that closed interval. Okay, so a couple other things with definite intervals, some more properties that we're going to be dealing with. If f is defined at x equals a, then the integral from a to a of f of x dx is going to just be 0. Okay, that's just going to be a straight up 0 because I'm subtracting this piece of a function, so you're doing the f of a, really, and then you're minusing off that f of a as well, so that's why it's going to be 0. In this case, if f is integrable on that entire interval and c is in between the values a and b, then I can break up the integral from a to b of f of x equals a to c, and then from c to b. That's very similar to what we did up here, where, let's see, up here where we, like, from 1 to 6, I had to break up this piece here and then this piece here, right, 6 minus 3. Instead of going from 1 to 6, I had to break it up into multiple different intervals. So that's very similar to what we did there. That shouldn't be anything new. Number 3 is if I'm taking the interval or the integral from a to b of k times f of x dx, because k is a constant, I can actually just take it out front and go from a to b of f of x dx, and that's the same thing. From a to b, number 4, if I'm going to take the integral from a to b of f of x plus g of x dx, the property states that I can split the integral up. So anytime you have a plus or minus sign, technically this could be a minus there as well. So from a to b of f of x dx plus minus, and then from a to b of g of x dx. So I can split that integral up that way. If f of is an even function, then the integral from negative a to a of f of x is going to be 2 times the integral from 0 to a of f of x dx. And you're like, what? Well, that doesn't really make sense. Yeah, well, it kind of does. So if I come up here, what's an even function? An even function just means it's symmetric over the y-axis. So I'm going to use x squared for right now. So here's x squared. Okay, and so if I want to find the area from 0 to 2, which, so that's up here, I want to find the area under here, and it's also from negative, so it's from negative 2 to 2. Well, that's the same thing as going from 0 to 2, 0 to a, okay, so this is a and that's negative a, 0 to a, and just multiplying it by 2, right, because it's an even function, symmetric, and that's why I'm able to say that. Part number 6 there, if f of x is an odd function, then from negative a to a of f of x dx is going to be 0. So in this case, if I took a odd function, which is a cubic function, that's just an example of one. That's a terrible cubic function. Let's see if I can redo that. Maybe I can make it a little nicer. Okay, that's a little bit better. So if I want to find the area from a, and this is negative a, okay, that means that this is going to be 0, or this is going to be negative something, this is going to be positive something, and they're going to cancel out. So an odd function is rotationally symmetric, 180-degree rotation, rotationally symmetric around the origin. So that's why you're going to get 0 there. Okay, let's go up and finish this stuff up on the last 2 examples. Yep. All right. So if I have a function that is from 2 to 4, f of x dx equals 5, and then from 2 to 6, f of x dx equals negative 6, what's the value from 4 to 6 of f of x dx, the integral there? So if I want to find, if I know that the integral from 2 to 6 of f of x dx is equal to the integral from 2 to 4 of f of x dx plus the integral from 4 to 6 of f of x dx. So that's technically true, right? So this integral here is the full integral right there. So that's going to be negative 6. This from 2 to 4 I know is 5. And I want to find out what that is. So I can just do some simple arithmetic here. From 4 to 6, f of x dx, and therefore if I subtract it I get negative 11, right? Negative 11 is equal to the integral from 4 to 6 of f of x dx. Okay, that's simple, just arithmetic, just kind of plugging and chugging some different values. Next one, and we have some fractions here, but that's okay. So if I have if x squared from 1 to 3 is 26 over 3, from 1 to 3 is 4 of x, and then from 1 to 3 is just a constant is 2. What I can do here is I can break this polynomial function up because it's separated by pluses and minuses. I can separate that stuff up to finding out what my answers are, right? So technically, this is the same right here as saying that negative the integral from 1 to 3 of x squared dx plus 4 times the integral from 1 to 3 of x dx minus 3 times the integral from 1 to 3 of just dx. Now technically there's a 1 there, right? So now I just want to do the math. And so the integral from 1 to 3 of x squared dx, it tells me is 26 over 3. So that's really negative 26 over 3 because that negative out front. This is the integral from 1 to 3 of x dx, which is right there is 4. So that's really plus 16 because of this 4 out front. And then the integral from 1 to 3 of 1 dx is 2. So that's 2 times 3 is that's then 6, right? So I get 16 minus 6 is 10. So negative 26 over 3 plus 10. So that's 30 over 3. So that's going to be 4 over 3 is your answer, fully simplified and all. Okay, that is it for this video. I think. I don't think there's anything left. There isn't. Okay, so that's it. And then you have your AP questions, and then we're going to start some more integral stuff. So, cool beans. Actually, I don't know. We have some. Yeah, we have something. I don't know. But deuces.